Welcome back to RStudio. This tutorial we're going to compute regression, specifically multiple regression. Let's load our Google correlate CSV file and put that into a data frame. And next let's look at what's inside of that data frame. We have again 51 observations and 9 variables. The 51 is for 50 states and the District of Columbia. And so we're going to create a regression model, and in this specific formula, LM is for linear model, and the tilde is, I guess you can loosely call that as a function of. So in other words, if you're looking at a linear regression model in a planar world, the y-axis and the x-axis, the as a function of would be considered on the left-hand side. So the dependent variable, sometimes it's called a response or an observation variable, is in this case the data viz. You can see here data viz and then the tilde. And the other variables are the independent variables, and sometimes they're called the predictor or the explanatory variables. And I guess different books have different names for them. And also notice that the predictors that I'm using are, some I've selected here are the quant variables, and other are not quant variables or categorical variables. For instance, to get the degree, we got stats_ed, Facebook, NBA, whether the state has an NBA team, and what region they're coming from. So notice stats_ed, you recall, was a yes/no variable, and the region was a 4-level categorical variable. We had 4 different regions. R resolves this. It's smart enough to understand what the issue is here to avoid some issues on the regression. So I'm putting this stuff into a data frame called reg1 for regression 1, and I'm saying the data selected is from the Google data frame that I created earlier. So let's run that, and you can see down here that it's created it, but it doesn't really say anything. We have to really tell R that we want to look at what we've just created. So let's look at the summary of the regression model. So there's a lot of things going on here. Let's look at those lot of things. We can see that we've called for a linear model, and that linear model is, as we had just discussed, and that is we're looking at the data viz versus the other predictor variables, and that we have some residuals, and the residuals basically tell you how the model fits the data that was analyzed. And so notice here, down here on the left hand side, we have all of our variables. We have stats_ed yes, and that yes, R has chosen on a yes/no variable to select yes as 1. And that's how R resolved the issue of the categorical transformation. And so therefore no is a 0. We have the Facebook NBA, and then we have has NBA yes, same sort of pattern. And notice here we only have 3 regions. So why only 3 regions? I noted right here, R wants to avoid collisions of it's actually multi-collinearity. Google that to find out what it is. Pretty somewhat complex, but after you've understood the prior issues in statistics, it's not really rocket science. So let's look at the estimates column here. The estimates show they're actually the coefficients for the regression model for each one of the predictors. It's the regression coefficient for degree is 0.9032 and change, and so forth. And the t-values in the F models are used for inferential testing. And then the last column over here is the significance. You can see that the asterisk represents those sort of predictors that have statistical significance. Remember, statistical significance was determined if anything under 5% with we were looking for something on a 95% level, and anything under the 95%, that is 5%, is statistically significant.